Okay, so we're going on to our next velocity versus time graph for Physical Sciences 3. And this time we have the vertical motion of a ball thrown upwards, and we have done this experiment in class. I don't think we quite got a speed of 40 meters per second to start off with. When we calculated it in our class, it's going pretty quickly, 40 meters a second. Okay, so what was the initial velocity? Well, I just said that, so 40 meters per second, and this is up. So we've got positive direction is up, so 40 meters per second upwards. Actually, let's call that u. Initial velocity is u, so u equals 40 meters per second upwards. What happened at 4 seconds? Well, at 4 seconds, our velocity is equal to 0. 0 meters per second. And what does that imply? That implies that we reached our maximum height. Okay, because it has to stop. So it gets to its highest point, then it stops, and then it falls back down. What was the acceleration of the ball at 2 seconds, 4 seconds, 6 seconds? Okay, so for all, it is just initial, it is just for all t, a equals 9.81 or negative 9.8 meters per second squared, and that is acceleration due to gravity. And you should be able to, and so what you can do is calculate this line. So this, if we actually, because it's a graph, we'll probably find that if we calculate the rise over run, then the graph probably says that it's going to be 10. And we could see that, like if we have a look here at 2 seconds, and we look at the rise over run, we can see that it drops by 20 over 2. So rise over run is equal to 10. That is close to 9.81, so negative 10 I should say. Negative 10 goes down 20. Okay, so if we're doing it by the graph, we probably should do the rise over run equals negative 10. But we know that it's equal to 9.81 meters a second because due to gravity, so I'm probably being a bit lazy here by stating that. So technically, if you're given a graph, you should just go off the graph. But anyway, what happened at 8.0 seconds? 8.0 seconds is here. So when the ball has now reached the same speed, but in the opposite direction. So it's going downwards at 40 meters per second. And that happens when it reaches its point where it's thrown at. So it returns to the height from which it's thrown. With v equal to minus 40 meters per second, which is equal to 40 meters per second down. Okay. And they are all our velocity versus time graphs. So there's some examples that you can practice in your problems book.